Okay, this is update test 4, part 6. I've redid my janky switch again. Got the motor running a little better. I haven't changed anything from the original setup. Same run battery, same charge battery. It's only been running about an hour and a half now. So we're probably at about the 73-hour run mark drawing off of this battery that started out at 12.65. This one was at 1.74 the 70 some hours ago. I've changed my circuit slightly. The only difference is that now that the rectifier that's across the transistors isn't being dumped back into the charged battery circuit. It's just being put into the cap and not even used. It brought my RPMs up just a tiny bit. I thought maybe it was some oscillation going on. I thought maybe, so I just unhooked it. It's running fairly nice right now. As you can see, it's pushing it up to 11.65. It's been kind of holding steady there for about the last 4 or 5 minutes. I'll show you the new janky switch that I made. We'll see how long this one lasts. I'm going to kind of pay attention to it. I'm just going to continue the test for now until I get my new reed switch and Hall effect sensors in, because I ordered a couple different types. Hall effect, reed, transistors, so I could try a couple different combinations to find the best for my situation here. Let me show you this reed switch I made real quick again. I'll turn the light on it in a minute so you can really see it, but I just wanted to kind of show that maybe if you could see it. It's a rarity that you even see a spark coming off this thing now. I mean, this motor could run way better yet. Like, I'm just doing what I can do right now to watch it run and do some tests on it and see exactly what's possible with this thing. So let me get this light on real quick, see if it's, so maybe you can get a little better look at my switch here. Believe me, it's not a masterpiece. Big coil wraps are basically just for a frame so I could hot glue it to down. So I'm going to shut it off real quick, let it stop, settle down so I can see where the voltages are after an hour and a half. This when I started it up earlier, it said 11.2, settled the voltage, and that was basically over, I don't know, 8-10 hours of sitting, both of these. And see where it's at, and I'm going to fire back up and see how long this reed switch lasts. And hopefully my parts get in here by Wednesday. If not, I'm going to just keep doing what I'm doing. So let me stop it real quick. Remember that positive feedback loop? Like, I really believe that circuit that I'm running is helping the run battery a lot, because it's allowing only the positive feedback from the whole system to come into the battery. If I'm catching any wrong direction back spikes, it's very, very rare, I believe. Because when I unhook the pulse motor here and this thing just continues to run with the flywheel a little bit, you can see the voltage that's being pushed back to the dry battery. So if you take your 12 volts and then whatever's kind of coming back, like there's that differential pressure. So if this is only putting out 4 volts and there's 12 volts here, so you got 16 volts of pressure in the system doing this. Like, I really won't know how well this circuit works till I put many hours on it and get the RPMs up to where it's actually running and pushing back faster on the charge battery. Like, and then we might actually see recovery while it's running over here to charge the same run battery as the battery that you're charging, which is kind of a radical concept. Like, but from what I'm seeing, like, if it's just the efficiency motor and the circuit has nothing to do with it, like, cool too, but just to try to wrap your mind around what it's doing. Like, I'm gonna shut it off here now. We'll watch this positive feedback as the motor slows down. We'll let it settle out real quick, see where this voltage is at, and then I'm gonna start it back up and see in about 12 hours or so. There's no negatives on that. I'd almost swear if I had super caps that could hold lots of amps, that this thing would almost run itself if it didn't. $11.57. So this light on again. We're going to draw her down. All right, when I start this next 12-hour test up, I'm going to get it, just give me a good reading from where everything's sitting, and then what the results will be after this next 12-hour run. As I get these RPMs up even higher, I think I'm going to see some really good results out of this battery charger. We got a load on it. I mean, it ain't drawing that much. They're LEDs. So you can see how dead the battery actually is, because the LEDs are sucking it down. I should hook a bigger bulb up, but we'll just do this for a minute, let her come down. While that's coming down, I'll show this circuit again, just in case nobody could read it off the board before. I don't know if we're going to be able to get it in here. Let me turn this light back on. You're getting the fancy paper today. So it goes from the positive of the battery. I'm not using no power regulation source. Like, it's running straight to the battery. So it's getting full bore. Maybe the transistors, the N-type, are only allowing so much current to come through, but I don't have a power supply or nothing on this thing. So it goes right from the positive of the battery to the inner coil closest to the magnets on the wind turbine, the negative of the battery goes to the negative on your N-type transistor. Now, coil 3, the very outer coil, because the wind turbine's got 3 wires that's coming out of it, the very outer coil runs to the output of your transistor, and then the signal wire on your transistor, basically on the N-type, goes through to the ground on the transistor, and the signal wire go to my reed switch so that it opens and closes the transistor. There is a rectifier across the reed switch and transistor. I was hoping that would help control some of the back spikes. Now the center coil on the wind turbine, its wire runs out and comes into a rectifier, which the other wire for the rectifier is coming off basically the ground on the outer coil. So this is the only place that I'm really collecting from is 2 and 3 here. The middle and very outer, I'm driving with 1 and 3. Now both of them go down into that rectifier, and it goes from the rectifier into my battery charger over there, which just has a battery charging circuit on it. It's nothing fancy. I imagine it's just a couple diodes in there and a small capacitor. And then after it goes from the battery charger thing, it goes to the charge battery. I mean, literally, that's how simple the circuit is that I'm running. So, like, if anybody wanted to try to put one of these together or whatever to see these results on it, how efficient this thing is, like, this is all I'm doing. Okay, the light's still on. Turn this off. It says it's at 9.4746 with the light on. It's still coming down a little bit. So it's still pretty freaking dead, but it's only been running an hour and a half since I started it back up. See where it comes back to. It's instantly jumping back over 10. We're going to hit 11 here. There's the 11 volts again. Earlier I said when I started it out, and it was at 11.2. So we're about 11.10. 11.2. I bet it'll go to that. We're not going to wait on it. I'm just going to get on with the test. Video's long enough. The drive battery currently, after sitting out. Make sure this motor don't start up here. The drive battery is currently at, it says 12.52. 12.52 is what I'm going to go with my resting voltage. And I'm going to start it back up. Give it a second for the battery to start accepting the charge again. I'd say that it's definitely putting out real power. But anyways, long enough video. Thanks for watching. See you in 12.